Hi everyone, how are you all children? I hope you people are keeping yourself good, fit and healthy and also enjoying the long vacation in spite of your busy online classes. Right children, now let us go into the lessons of today. Today's lesson is all about the continuation of the lesson which we have already started with, and it is motion. So, under motion, we have discussed a lot in the previous classes like displacement, distance, speed, velocity, acceleration, etc. Also, we have solved some of the numerals based on these concepts. Further, today we are going to extend the learning process for this type of motions under graphical representation. So, any type of motion can be represented in the form of a graph, and from the graph we can able to predict what type of motion does the body have. Children, this topic, that is the graphical representation of motion, is little clumsy and it needs lot of your attention. Unless you listen to it very carefully and unless you understand it, it becomes difficult. At the same time, once when you understand the concept, then the things are very easy. So, try to pay more attention in this class because it involves the graphical representation as well as calculations from the graph. Therefore, children, you please attend this class very carefully. Right. Now, graphs for motion can be classified into two: distance time graph and velocity time graph. Distance time graph, distance is taken on y-axis and time is taken on x-axis. In many of the cases, when we draw the graph, time is chosen as x-axis. So, as well, in velocity time graph, velocity is taken in y-axis and time is taken in x-axis. So, what are the possible graphs that we come into the picture that we are first going to see? And when we see the graph, what are the things we can predict? What type of motion it has, we can predict. More than that, we can calculate a few physical quantities from the graph. For example, from the distance time graph, we can find speed by finding the slope of the line. And in the case of velocity time graph, we can find acceleration as well as the distance covered by the body. So, for all this, we need calculation. We need to calculate what are the things we have to calculate. All this we will see in detail in this class. So, as I told you children, please listen and understand the concepts thoroughly. In case of any difficulties, please call me. I am ready to help you anytime. Children, now we will go into the class now.
Yes, children, let us now go into the lessons in detail. So what we are going to discuss today is about the graphical representation of motion. So any type of motion can be represented in the form of a graph, and from the structure of the graph we can predict about the nature of motion, and that's what we are going to see in today's lesson in detail. This graphical representation of motion can be broadly classified into two types. One is for distance time graph. The other one is for velocity time graph. So in distance time graph, distance is taken in y-axis and time is taken in x-axis. And similarly, in velocity time graph, velocity is taken in y-axis and time is taken in x-axis. So here are the blank graphs which are being shown here. So you can see a similarity in the x-axis. Always time will be represented in the x-axis. And also I would like to recall that distance is a scalar quantity and displacement is a vector quantity. And distance divided by time will give you speed. Displacement divided by time will give you velocity. So the space in between the graphs can be of any type of line. So let us see in detail what type of lines can be accommodated in these empty graph and what do they predict upon. Children, look at the slide which is being given here. All this slide has one thing in common, that is all this graph represents for distance time, or else it can even be displacement time. So you have different types of line in the graph. So each of the line predicts a certain type of motion. Look at the graph A. It has a slanting line. It has a slanting line between displacement or distance and time. When the graph is like this, it represents the body is moving with constant velocity. And look at the graph B. There are two graphs in B. Both of them are parallel to the x-axis, but the graph on the right is just closer to the x-axis, whereas the other one, it is little far away from the x-axis. But both of them are parallel to the x-axis. So what does it mean? You study the graph carefully. Is there any increase in the distance? The distance remains the same. So wherever you take a point on the line, the distance remains the same, but the time is increased. So what does it mean? It means the body is at rest. When the body is at rest, will there be any speed or will there be any velocity? Absolutely no. Therefore, both these graphs represents the body is at rest or it has zero acceleration. And look at the graph C. It is a curved line. And look at the graph D. It is also a curved line but opposite in nature of C. The curve C represents acceleration, whereas the curve D represents deceleration. What do you mean by acceleration? We have already seen it. The increase in speed is called acceleration and the decrease in speed is called deceleration. For example, if you want to ride your bicycle, at the time of your start, your speed will be less. And as you go on pedaling, the speed increases. So we say here the speed is increased. Therefore, it is called as acceleration. At the same time, a stopping where you want to stop your bicycle has come. What do? You apply the brakes. So when you apply the brakes, what happens? The speed obviously reduces. So in this case, the speed is reduced. Therefore, we call it as deceleration. So these graphs are very important graphs as far as distance time graphs are concerned. Constant velocity, the body is at rest, accelerating body and decelerating body. So these are the various types of distance time graph and this you have to bear it in mind. Children, here in this slide, we are going to study in detail about the first type of distance time graph, where the line is slanting. So what does it represent? It represents the body is moving with constant velocity. Now, let us analyze it in more detail. What do you mean by constant velocity? Already we have seen the definition. If a body moves equal distance in equal intervals of time, then the motion is said to be with constant velocity. Now look at the table which is given in the green. Let us take an object which travels 10 kilometers for the first hour, 20 kilometers for the second hour, 30 kilometers for the third hour, and 40 kilometers for the fourth hour. So here you can see the time is at a regular interval of 1 hour between the first and the second. And similarly, when you examine the distance covered by the body, it is also with 10 kilometers. So you can take the first two readings here. For the first hour, it covers 10 kilometers. For the second hour, it covers 20 kilometers. What is the time difference? 1 hour. What is the distance covered? 20 minus 10, it is 10 kilometers. So similarly, you can see for every 1 hour, the body covers 10 kilometers. So when the time is uniform, distance is also uniform. So the body covers equal distance in equal intervals of time. Now let us plot these values in the graph. Now look at the graph here. The time is taken in x-axis and the distance is taken in y-axis. So there are 4 points plotted in the graph according to the table given here. Now when you join all the 4 points, you get a sloping line, inclined line. So this line represents the constant velocity which is possessed by the body. Children, look at this slide very carefully. How are the lines? The lines are broken. They are not straight. What is the reason for these broken lines? Let us examine with the help of the tabular column which is given on the right. When you look at the table, it gives the value of time as well as the distance. For the first hour, it has completed 5 kilometers. For the second hour, it has completed 15 kilometers. And for the third hour, it has completed 20 kilometers. How are the intervals of time? They have equal intervals, 1 hour, 2 hours, and 3 hours. Therefore, the times are with equal intervals. But what about the distance? 5 kilometers to 15 kilometers. So how much is the distance travel? 10 kilometers. From 15 to 20, 5 kilometers. Is the distance covered? Is it having regular interval with respect to time? No. Though the time is with regular intervals, the distance is not with equal interval. Therefore, the body is completing unequal distance in equal intervals of time. So, as per the definition, this is non-uniform velocity. So, for a non-uniform velocity, the graph will not be a straight line and it will be a broken lines, and this you have to bear it in mind. Children, we are going to extend the study still deeper for the distance time graph, and for a body which travels with constant velocity. So we have seen for a body which moves with a constant velocity, the graph is a slanting graph. Now let us take another example here. Look at the tabular column here. For the 20 minutes it has covered 1 kilometer, in 40 minutes it has covered 2 kilometers, 60 minutes it has covered 3 kilometers, and 80 minutes it has covered 4 kilometers. Now when you examine the time, they are at regular intervals, each 20 intervals. When you examine the distance also, they are at a regular interval of 1 kilometer. Therefore, the body covers equal distance in equal intervals of time. The same readings are being represented in the graph. Time is taken in the x-axis as 20, 40, 60, 80, and the distance are taken in the y-axis as 1 kilometer, 2 kilometer, up to 5 kilometers. Now plot the points, you get 4 points and they are shown there in the graph, and connect this and you get a very beautiful straight line. From this straight line, we are going to calculate the speed of the body. How to find the speed of the body? Now how will you find the speed? From the formula. So look at the right hand side graphical part. So speed can be calculated by the formula distance divided by time. How much distance it has traveled and how much time it has taken, and when you divide both of this, what you get is the speed. And this is arithmetic calculation. Now the same speed can be calculated using the graph. So this, see the formula distance. Where are these distance values are being plotted? In the y-axis. And divided by time. Time, where are the values of time plotted? In the x-axis. Therefore, speed from the graph is calculated with y-axis value divided by x-axis value. And this way of finding the y-axis value upon the x-axis value, it is called as slope. So in short, if we want to find the speed of an object from a graph, then we need to find the slope. If we find the slope of a distance time graph, then it represents the speed of the body. Now how to calculate the slope of this line? We will see it in the next slide. Children, this graph is the most important graph because this is going to guide you how to find the slope of the straight line, slanting straight line. Therefore, you need to observe this slide more carefully. How to find the slope? If we find the slope, then the value of the slope will give you the speed of the body which is traveling here. So we are seeing for a body which travels with a constant velocity. Now the graph will be like this. It is a slanting line. In the slanting line, you take any 2 points. Listen here very carefully. You take any points on the graph. It can be anywhere, but it should be touch the line. So let me call the points as A and B. Now drop a perpendicular towards the x-axis. Since the x-axis has the values of time, let us have this value as t1. Similarly, drop a perpendicular down to the point B. Let that be t2. Similarly, from the point A, you just draw a parallel line to the x-axis where it touches the values of y-axis where distance is taken. Now let us take that distance as S1 for the point A. Similarly, you draw again a parallel line to the x-axis where it touches the graph at the point S2. So for the point A, the coordinates are S1, T1, and for the point B, the coordinates are S2 and T1. Right, now how to find the slope of this? We have already seen the slope is y-axis value divided by x-axis value. So the y-axis values are S1 and S2. So the difference between these two is given as S2 minus S1 divided by the x-axis value T2 minus T1. Therefore, the slope can be easily found out by the coordinates S2 minus S1 divided by T2 minus T1. In this way, we can identify the slope of the graph, and the slope of the graph will give you the speed of the body covered in that motion. Children, in the last slide, you have seen how to calculate the slope from a distance time graph, and it is given by the formula S2 minus S1 divided by T2 minus T1. Now look at this graph carefully. It is the actual representation of a body which travels with uniform or constant speed. The line is a slanting line, and in that line we have taken up 2 points, point A and point B. Now when you look at the point A, the S1 reading is 10 meters and the time is 5 seconds. And for the point B, the distance is 20 kilometers and the time is 10 seconds. So here S2 value is 20, S1 value is 10, T2 value is 10 and T1 value is 5. So the slope is represented by the formula S2 minus S1 divided by T2 minus T1. So substitute the values for S1, S2, T1 and T2. So you will get 20 minus 10 divided by 10 minus 5, and when you simplify you get 2 meters per second. And for this body which travels with constant velocity, the speed of the body is 2 meters per second. Now we will pass on to the next type of graph, which is velocity time graph. So you have numerous examples of velocity time graph in this slide. So each and every one has a unique type of motion, and let us study in detail for each of this. The graph A, look at the graph A, velocity is taken in y-axis, time is taken as x-axis, and the line is parallel to the x-axis. So what does it reveal? That means there is no change in the velocity, there is no change in the speed of the object. That means the body is traveling with a constant velocity, no increase in velocity nor decrease in velocity, and we call it as the body is traveling with constant velocity. Now pass on to the graph B. The line is a sloping line, a slanting line, as we had seen in the distance time graph. There it was for distance and time, now it is for velocity with the time. So what do you get when velocity is being divided by time? Obviously, it is acceleration. Therefore, the body here travels with uniform acceleration. Now, look at the graph C. The shape of the line is exactly opposite to that of B. So, where it represents uniform deceleration. I already told you children, deceleration is negative acceleration. And now look at the graph D. Now this line is little above the origin. So this possesses initial velocity as well as final velocity. For any moving object, we have already discussed, it has two types of velocity, initial and final. So this graph has initial velocity as well as final velocity, and since it is a sloping line or a slanting line, it also travels with uniform acceleration. Now the next graph E is a curved line, so where it represents the motion is non-uniform. Therefore, children, this is a non-uniform accelerating motion. And for the last one, it is a combination of all. A to B, they represent uniform acceleration. B to C, they represent constant velocity. And C to D, it represents the deceleration of the body. So it is a combination of all types of motion. Now children, let us analyze more of the velocity time graph as far as the slope is concerned. Previously, you have seen how to find the slope of a line, slanting line, S2 minus S1 divided by T2 minus T1. Here, we are seeing with velocity time graph. The slope of the velocity time graph gives you the value of acceleration, and that's what it is given in the blue border. Slope of a VT graph, which is equal to acceleration over that interval of time. Now, how will be the slopes for the following lines? Now you see to the first line, the line is parallel to the x-axis. That means its velocity or speed remains constant. Can you find a slope for this line? You cannot find a slope for a parallel line. Therefore, the acceleration is 0. Similarly, come to the next right side. Here is a slanting line. For this type of line, we had already calculated the slope in the case of distance time graph. So we can easily find out for this type of graph, only here the value of velocity is taken in y-axis and time is taken here in x-axis. So the slope which you find out from the graph is a positive slope, and the body travels with constant constant acceleration. Now look at the next graph. The line is exactly opposite in nature of the previous graph. So we have already seen that this line represents decelerating motion, and so we can find out the slope of this line also, but the value of the slope will be negative, which indicates that the body is with a negative acceleration. And for a curve, we cannot find the slope. Only for a straight line we can find the slope. For a curve, it is not easy to find the x coordinate and y coordinate, which are supposed to be in the straight line. So slope is a curve, therefore acceleration here it is not uniform. So this is how the variation of the sloping differs from graph to graph. That means from the nature of the movement from one moment to another. Now let us move on to the calculation of acceleration from velocity time graph. How to find the acceleration from velocity time graph? To find acceleration, we need to find the slope of the velocity time graph. So we have already come across how to find the slope of the slanting line. Slope is also called by the word gradient. Gradient and slope both mean the same. So a model graph is being given for a body which travels with constant acceleration. So we have to fix any 2 points on the graph, A and B, and take the coordinates of T1 S1, T2 S2, and the slope is given by S2 minus S1 divided by T2 minus T1. So the gradient of a velocity time graph gives the acceleration. Children, we have learned how to calculate the acceleration from the velocity time graph in the previous case. Now we will extend from the same velocity graph. How can we calculate the distance traveled by the body? The distance traveled by the body from the velocity time graph is easily calculated by finding the area enclosed by the line. You have to find the area enclosed by the line. So let us see example for two of the graphs here. One graph is with white and the other graph is with black. Now let us take the left side graph which is with white. Now it is a speed time graph and the red color line OA indicates the nature of motion, and since it is a oblique line, the body or the object travels with uniform acceleration. Now for this type of motion OA, how much is the distance traveled by the body? So the distance traveled by the body, we have to calculate the area enclosed by the line. So the line is OA. So drop a perpendicular from A and it will touch the point B on the x-axis. So what is the area under the line OAB? So it is a triangle. So OAB is a triangle, and how to find the area of the triangle? The area of the triangle is given by half into base into height. So the mathematical formula for calculating the area of the triangle is half into base into height. Now here the base OB is the base and its value is 5 seconds or hours as it is given, and height of this triangle is being given by the distance AB, and when you look parallelly into the y-axis, the distance AB is equal to 50 meters per second. So substitute in the formula, area is equal to half BH, half into base 5 into height 50. So you will get 125. So the distance traveled by the body is 125 meters. Now we will go for the black color graph, right side graph. Now AB is the line which represents the motion. So for this velocity time graph, here is the line AB. When the velocity is taken in the y-axis and time is taken in the x-axis, in the figure it is given wrongly, x-axis and y-axis. So AB line represents it moves with a constant velocity, we have seen already. So when the body AB travels with the constant velocity, how much is the distance covered by this? So here the line is AB. So drop a perpendicular from A, it will meet at the point C. Similarly, drop a perpendicular from B, it meets at the point D. Now what is the figure ABDC? It is a rectangle. So area of the rectangle is given by the formula length into breadth. The length is given by CD and the breadth is given by the height AC. So choose the values from the graph if it is there, and find out the value of the length with the breadth, and when you multiply the length with the breadth, it will give you the area enclosed by the body. Children, we have seen that area under velocity time graph gives you the distance covered. Now let us take an example and plot it in the graph, and let us try to prove the area enclosed by the curve gives you the distance. Now we are going to calculate the distance covered both in terms of formula and in terms of graph, and we are going to prove both the answers are going to be one and the same. For this, you look into the graph which is on this slide. Now AB, the line AB represents the motion under velocity time graph, and since this is a line which is parallel to the x-axis, the velocity remains same, so the body travels with constant velocity. Now let us take the formula. We have the formula velocity is equal to distance traveled divided by time. Here S is the distance traveled and T is the time. So from this, distance traveled is equal to velocity into time. So by formula, we can calculate the distance traveled by multiplying the velocity with the time. Now look into the graph and find out what is the value of the velocity. For the line AB, the velocity is 20 kilometers per hour. And look into the time. The time values are, the A time is 5 seconds and B time is 15 seconds. Therefore, the total time total time taken by the body to move from A to B is 15 minus 5. That will be 10 seconds. So when you multiply the velocity 20 with the time 10, you get 200 meters. So this 200 meters, we got it from formula. Now let us take the graphical calculation. So according to the graphical calculation, the area enclosed by the curve, here the line is AB. Drop a perpendicular, it will meet x-axis at the value of 5, and similarly the perpendicular at B will meet the value 15. Now A, B, D, C is a rectangle. Now the area of the rectangle is given by the formula AB into BD, that is length into breadth. AB, the length of AB is 15 minus 5, 10, and the length of the line BD corresponding to the y-axis is 20. So 10 into 20, 200 meters. So in both the cases, by formula method as well as by the graphical method, we have shown that the distance covered by the body is one and the same. So in short, if you want to find the distance traveled from a velocity time graph, then find the area enclosed by the line. Children, we will analyze the distance traveled for a graph, velocity time graph, where we are encountering two figures. a triangle and a rectangle put together. So let us see into the problem here. If a body whose velocity is increasing with time, the graph is a straight line having an increasing slope. This is because the velocity increases by equal amounts with equal intervals of time. The area under velocity time graph is the distance, that is the magnitude of the displacement of the body. The distance traveled by the body between the point A and E is the area A, B, C, D, E under the velocity time graph. Now, observe the graph being given here. The motion of the graph is given by the line OAE and it extends. So, since the line is a sloping line, it is a constant acceleration graph. Now, how much is the distance traveled for this line? Now, the distance traveled for this is not calculated from O. If you are want to calculate the distance traveled from O till the end, you can find the area of the triangle. But the question here is, what is the distance traveled between the point A and E? So between the point A and the E, what is the distance traveled? So the distance traveled by the body between the point A and E is the area enclosed by the line AB. Now drop a perpendicular from A, it will meet the x-axis at B. Similarly, drop a perpendicular from E, it will meet the x-axis at C. Now the total figure that you get is represented on the left side, one with a triangle and another with a rectangle. So A, B, C, D, E is composed of two figures, one the yellow color part triangle and the blue color part rectangle. Now find the area of the triangle and find the area of the rectangle and add both of this, you will get the total distance. So area of the triangle is given by the formula half BH, therefore half into base 20 into height 20, that is equal to 200 meters. Similarly, area of the rectangle, length into breadth, 20 into 10, that will be 200 meters. So the total distance traveled is 200 plus 200, that is 400 meters. This is a lengthy way of calculation. Now, the whole of the figure, if you look at, it is a trapezium figure. The figure on the whole, instead of dividing into two figures, a rectangle and a triangle, if we look at one figure, then the figure A, B, C, D, E is a trapezium where AB is parallel to CE or EC. So here the two parallel sides of the trapezium are AB and EC, and height of the trapezium is BC. Now the formula for the trapezium is half h into A plus B, where h represents the height and A and B represents the parallel sides. So substitute the value height as 20, A one of the parallel sides at 30 and B other parallel side at 10, and simplify, you will get the same 400 meters. So children, if a distance being asked and if the figure is a trapezium, you can calculate in two ways, but that is by calculating the area of the triangle and the area of the rectangle, then you can sum it up, or you can do it shortly using the formula of the trapezium half h into A plus B. Therefore, children, this is a very important slide which gives you the important calculation of the trapezium formula. Now, let us put all the knowledge that we have gathered so far in this graph and try to solve the problems. Now, look at this problem here. The velocity time graph shows the motion of a particle for 1 minute. Calculate each of the following. Now observe the graph. Velocity, time. So velocity is taken in y-axis, time is taken in x-axis. So it is at regular intervals of time 10, 20, 30 and 40 right now. We will see what is the question one by one. And before that, you see into the graph. It starts from O and then it goes steep and then the line is rendered parallel to the x-axis, and after that it comes back again, touches the point 0 of the x-axis. So this is the shape of the graph. Now we'll see the questions one by one. The acceleration in the first 10 seconds. So we are being asked to calculate the acceleration in the first 10 seconds. And the acceleration is for the sloping line. So the sloping line has a height of 6 meter per seconds. So, and the base value is 10 seconds. So acceleration is calculated by the formula slope. So slope has the formula y2 minus y1 or s2 minus s1 divided by t2 minus t1. So 6 divided by 10, that is equal to 0.6 meter per second square. So the answers are given at the right with red. Then the question B, the total distance traveled by the body. The total distance traveled from 0 seconds till 40 seconds. What is the distance traveled? Now this figure can be represented or divided into three figures. So the first figure is a triangle and the middle figure is a rectangle and the last figure again it is a triangle. So the distance traveled here is calculated with by finding the area enclosed by the curve with two triangles and one rectangle, or in short using the formula for trapezium half h into a plus b. Here I have represented with the blue color 30, 120, 45. So these numbers represents the distance traveled by the body when you calculate using the formula for triangle, rectangle, like that. So if you add totally, you will get 195, or this can even be easily calculated by using the formula half h into a plus b, where h is the height. Here the height is 6 meter per second, and parallel sides. One parallel side is 45 and the other parallel side is 30 minus 10, 20. So when you substitute the formula, you will again get the same answer, 195. The total displacement. So the body starts at 0 seconds and then it ends at 45 seconds. When the body is at 45 seconds, what is the velocity? The velocity is 0. When the velocity will be 0? When the displacement is 0, velocity is 0. Therefore, the displacement here is 0. Average speed. The average speed is given by the formula total distance divided by total time. The total distance here is, we have calculated previously 195 and the total time is 45 seconds. So when you divide both these, you get 4.3. So the average speed is 4.3 meter per uh, the average speed is 4.3 meter per second. Then the average velocity will be 0 because velocity is 0. The average velocity will also be 0. So this is a very important problem where it frequently is asked in by the board. So get prepared with by this type of examples and solve it of your own children. Now let us see another question of the same kind which had appeared in the board examination. The graph given below shows how three runners A, B and C ran a 200-meter race. Now you can see three different color lines in the distance time graph. Runner A, runner B and runner C. So let us analyze this. A and B are curves where the C, it is a steep line, then it is parallel to the x-axis and then again it is a steep line. Now answer the questions. Now first question, which runner won the race? Is it A, B or C? Now the distance remains same for all the three runners, 200 meters. A has completed in 9 seconds, B has completed in 10.5 seconds and C, he has completed in somewhere around between 12 to 14.5 or we can say 13 seconds. So who has completed the race in less time? It is runner A. He has completed in 9 seconds. Therefore, runner A is the winner of the race. That means he has covered 200 meters in 9 seconds. Which runner stopped for a rest and how long did he stop for? So who has stopped in between? So a line which is parallel to the x-axis means it is the body is under rest. Therefore, the runner C, the pink color line you see, a line parallel to the line parallel to the x-axis is being given here. Therefore, the runner C has taken rest in between. And how long? How long means time. For how much time he has taken rest. So what is the length of the line? So it starts from 6 and ends in 9.75 somewhere. So 9.75 minus 6, it will be 3.75 seconds. So the runner has taken rest for a period of 3.75 seconds. Third question, how long? How long again here it represents time. How long did the runner B take to complete the race? So what is the time taken by the runner B to complete the race? So as we have seen, it is 10.5 seconds. Then the last question, calculate the runner A's average speed. What is the average speed of the runner A? So runner has completed 200 meters and he has completed 200 meters in 9. So total distance divided by total time, 200 divided by 9 and 22.22 meter per second is the speed of the runner A. So finally, we will come to the conclusion, the summary of what we have learned. When objects cover equal distance in equal intervals of time, they are said to be in uniform velocity. Secondly, when the object covers unequal distance in equal intervals of time, then their motion is said to be non-uniform velocity. Third point, from the distance time graph, speed is given by the slope of the line. From the velocity time graph, the distance is given by the area enclosed by the graph. And also we can include the distance time graph. Speed is calculated by finding the slope, and the slope of a line can be found out by the y-intercept divided by x-intercept, S2 minus S1 divided by T2 minus T1. So the slope of a distance time graph gives you the speed, and the slope of the velocity time graph gives you acceleration. And the area enclosed by the body is the distance covered in a velocity time graph. Children, finally we have come to the end of today's learning session. In today's learning, we have seen about the graphical representation of motion. Motion graphs are classified as two: distance time graph and velocity time graph. And in distance time graph, when the line is steeper, when there is a sloping line, it represents the body covers equal distance in equal intervals of time, which represents constant velocity. And when the line is parallel to the x-axis, the body is at rest. When they are in the shape of a curve, either it is acceleration or deceleration. Then the second type of graph that we had discussed is velocity time graph. So under velocity time graph, if it is a sloping line, it represents constant acceleration. Now when the line is parallel to the x-axis, there is no change in the velocity. Therefore, the body covers equal, there is no change in the velocity. Therefore, the body travels with constant velocity. And a graph of curve represents the acceleration and deceleration for a velocity time graph. And the speed or velocity is calculated by finding the slope from the distance time graph. Similarly, the slope of a velocity time graph gives you acceleration. And more than that, the distance traveled can be calculated from velocity time graph by finding the area enclosed by the curve. So these are the observations we have seen today, children. So go through the slide, and this is a very important chapter in motion is concerned, and particularly the problem solving skills are expected more from you. Therefore, a wide knowledge of finding the slope is and the area is required. Therefore, children, practice more problems of this type by analyzing the questions given in your textbooks, as well as you can look for many examples which can be downloaded from the Google. Therefore, have a good day, and we will meet you same time next week. Until then, bye bye children. Goodbye.